In this section, we are going to look at some security considerations that you have to take care of. And the first part of that will be an overflow and underflow attack. Now, what is security considerations? Security considerations in a Solidity programming language or any program that you write is making sure that your application cannot be hacked or tampered or drained money from and things like that, right? Especially that becomes very important because of all the attacks that have happened in the blockchain world before, right? So a smart contract can hold money, right? And when a smart contract can hold money and it has some security issues, yeah, because it is immutable also, you cannot stop the server. It is running 24/7, right? And you cannot change it, redeploy it, you cannot fix the bug. All of these things becomes very important, and that's the reason why if you are working in a startup which is working on a blockchain based project, right, probably it will take 6 months for them to develop the smart contract, but at least a year to test the smart contract, correct? So it is that important to test the smart contracts before deploying into the mainnet of a blockchain. Okay, as part of this, first one we are going to see is overflow and underflow attack. Okay, so to explain this, I can take the example of your odometer in your car or whatever, right? And it will have, let's say, 5 digits, right? 00000.0, right? This is where it will start. Okay, and after you have run 15,000 kilometers, let's say 15,000.0, and then it will go to, let's say, 99999.9, right? Once you reach this point, that is the maximum limit for the odometer. If you go zero point 0.1 kilometer or 0.1 mile more, what is going to happen is that it's going to come back to 00000.0. It is going to reset, right? And this is a problem when it comes to Solidity programming, right? I'll show you in live as a demo how this can be depicted, right, so that we can understand what is the problem and how to solve that also. So let's go to contract and call this overflow, right? Now within this overflow, I'll create a integer 8. Okay, public a, right? Now I'm writing a function. Okay, function, let me have it as 127, right? Positive 127 is the maximum for a, right? So function, I'll call it increment. Okay, and public, what this is going to do is a plus plus, right? That's all. If I make it 128, it is not going to accept, but if I do 127 and do plus plus, there is no compiler error that is shown. Okay, because the compiler does not understand that there is a possibility for this to overflow, right? Overflow means going beyond the range, correct? Let's deploy this. Okay, not in ring B plus in VM. Yeah, does it have enough balance? We'll wait for the balance to pop up. Otherwise we can refresh the page. If you ever face this issue, just refresh the page, you'll get the balance back. Okay, so open overflow.sol, go back, let me make the font bigger, right? And now you can deploy this into JavaScript VM. So a is 127, right? It's an int 8, so it is from minus 128 to 127, correct? Call this increment function. It has been successfully done, and when you call a now, it becomes minus 128. What is the reason? Minus 128 is where it starts and 127 is where it ends. So if you do positive 127 plus 1, what's going to happen is it's going to go back to the starting range of minus 128. Probably this can be easier depicted in unsigned integer, right? It's from 0 to 255, right? So let me deploy this, okay, and show you a is 255. If you increment, a becomes 0, right? Okay, so what is the problem here is that what if a is not a variable but it's depicting a balance of a person, right? Let's say the person has 255 ether as balance, and he is adding one more ether to his balance. It will become 0, right? That should not be let happen in your smart contract. and that is called as the overflow attack. So as a developer, you need to test your contract so that these things are eliminated. Okay. So one way to do that is stay alert when you are creating this smart contract. But you can also use the OpenZeppelin library SafeMath to take care of this, right? Instead of doing balance plus plus, if you do, let's say, use OpenZeppelin and say balance dot add one, right? That will take care of the overflow issue. Okay. So I'll tell you how to solve this problem also, correct? So if you go in, a solution for this is that you require, okay, you require that balance plus plus, okay, is not less than, okay, which means greater than or equal to balance, right? So balance is 255. So if balance, it has to be greater than balance, it has to either be 255 or 256, right? We are fine with that. If it is not, say overflow, right? So now let's try to do that, if it is working or not. Okay, deploy, go to balance, it's 255, increment, and it will say balance is 1. Okay, I have done some mistake here. Balance plus plus is greater than equal to balance, right? Balance plus plus is greater than or equal to balance. Okay, balance plus plus become 255 is greater than balance. Oh, okay, I have not checked the result of it. Okay, let me just do balance equal to balance plus 1. Okay, so this can be done. I'll just put this after the thing and say balance plus plus, not plus plus. Balance is greater than, let me just say event 8 temp is equal to balance, right? So greater than equal to temp. Okay, now this should mostly work. Let's see, come here, check the balance 255, increment, it says overflow, right? And if you check the balance now, it will not be changed because this required statement did not work out. It will go back to the previous thing, right? So this is exactly what is checked in OpenZeppelin also. They have thought about it beforehand itself, right? Similarly, you can do something like this for underflow also, right? Overflow means going above the range, underflow is going below the range. If the balance is 0, let's say, okay, and you are doing balance minus 1, and this should be less than equal to, right? So let me just take it off so that you can understand what it is, right? So go to underflow, deploy this, and you can find balance is 0. If you call increment and call balance, it becomes 255, right? It has gone below the range and hence goes to the other side of the range. Yeah, so this is called as overflow and underflow attack. One of the most common this thing that happened in Bitcoin because of this overflow attack created 92 billion Bitcoins, right? 92 billion Bitcoins were created out of the blues, right? Because of an integer overflow that happened in 2016. So you can probably go look at this 92 billion Bitcoin problem and you will be able to find that how difficult is this overflow to handle, right? So if this has a problem, then your entire smart contract might face a huge security threat, correct? So solve this every time. Remember this. That's the reason why we have some things like OpenZeppelin kind of security tools, right? So use them so that your smart contract is very secure. We'll look at some other security considerations from the next video.